Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Folks, Al Martin here. Welcome to Making Data Simple. While I'm a fan of IBM technology, that's where I'm employed, I explore a ton of other companies, technologies as well. I like to learn. IBM's position is one that's hybrid and open anyway. So in the spirit of that openness, I have got a terrific guest for you today, Ami Gao. He's the CEO and co-founder of SQream. And as a bit of a lead in, I'll give an intro as I often do, and then I'm going to turn it over to Ami. But this SQream is a Big SQL analytics platform powered by GPUs. They're crunching numbers from like few terabytes to petabytes with high performance. As everybody on this podcast should know, Making Data Simple, of course, is the total amount of data creation is projected to grow to more than 180 zettabytes over the next 5 years. And SQream is taking on the data analytics industry, enabling organizations to ask bigger questions of extremely large, complicated data sets, no off-limit questions. They're maximizing data pipelines, they're predicting accuracy, they're responding to queries faster, and they are a processor with minimal total time to insights. Ami, thank you for being here. I've got a lot of questions already. I appreciate you joining the show today.
Hi, Al. It's great to be here. I've been looking forward to talk with you today.
Terrific. And you're in Tel Aviv, right? What time is it? It's like in the evening, yeah?
Yeah, it's like 6
You're working
p.m.
late.
In Tel Aviv. No, it's
Well,
like
that's not
the middle of the day for startups.
I like that. So, but no dinner or what? Am I in between you and your dinner or not?
No, the dinner is far, far away.
Far, far away. Okay. Well, if you would, again, I appreciate you being here. If you would, please introduce yourself, talk to your experience, and what brings you to SQream.
Yeah, so I've been around technology, especially around high performance technologies and computing since the early 90s. I was messing around with general purpose GPU algorithms since the mid of the 90s. And with SQream, it's an opportunity to completely, transform the way customers are getting insights from their unbelievable amounts of data and unbelievable complexity of queries required today in order to win. So for me, it's like a lifetime mission to enable clients to be able to get insights from their biggest assets, which are the data assets. I'm a chess player. I like to play chess, and I really like human machine interfaces and results that makes the world a better place.
Great intro. How good a chess player are you? You like the
Let's
best?
play.
Can't be beat?
No, I'm
I'll get beat.
I'm I'm not the best, but I can play a chess game.
Do you play often? Like weekly? Every week?
Play once every couple of weeks on one of these online platforms.
Yeah.
Quick games, slow games. It's just it's my brain's yoga. It's a kind of a brain yoga.
Nice. Hey, and
Yeah.
as I was doing research on you as well, you have a connection with IBM, don't you? A seed camp or something? I wanted to.
Yeah.
It said talked about IBM Accelerator. Could you talk to that quickly?
Yeah. So quite a few years ago, IBM GTU, one of the innovation units of IBM in Israel, they started a bootcamp plan for startup that is, and I was one of the mentors in that plan. I was happy to help around with the IBM ecosystem to innovative startups who or got through IBM Smart Camp in order to get the market.
All right, so let's jump in. Let me ask you a few questions. I'm gonna start easy. Why the name? How do you come up with the name? SQream.
Yeah. So we had we had a fantastic name, another name, and we ran fast to the registration office to register it, but it was already taken. So we had to register the company in that time because we were filing patents for the company. So we had to do something. So we sat 5 minutes with a napkin. We wrote the word SQL, vector, stream, and we decided to take SQL and stream, mesh it into one word, and SQream came out, and it's it has a joke inside it. This is how we got to SQream.
Nice. I mean, aren't the best ideas always? Don't they arrive via a napkin?
Yeah,
I
yeah,
think that's always the case.
yeah, yeah. That napkin did well.
Did you keep it? You should have kept it and framed it. So
I
when
don't
this
have
this
it.
completely takes no,
It was the responsibility of my co-founder to keep it, and he lost it.
that's it. Just like a startup, blame it on the
Yeah,
co-founder. I love it.
yeah,
All right,
exactly.
and I like your motto. At least I think it's a motto. And you talk about, or it says, "Ask bigger." Can you say more about
Yeah.
ask bigger? What do you mean by that?
So we the idea came from a discussion with one of our customers. So we went to one of these customers. He had a use case. He was using another MPP data warehouse, and he was always compromising on the size of the data. So he filtered the data and filtered the data. He wasn't able to run on all of his data set. And the customer told us, you when you arrived, I was able to run on all of my data, and I was able to ask bigger questions, right? So he was used to work on filter data because of issues around performance and scale. And so he told us, I asked a lot of small questions, and I really wanted to ask big, bad, ugly, and complex queries in order to get very important insights. So we thought about it, and we thought that's a nice slogan. We enable our customers to ask bigger questions, and this is how we come up to this specific term. It was an idea came from our customers, and a very good marketing guy who catch the frame and focused on it.
That's a great segue into my next question, which is, look, there's a lot of big players out there right now, particularly on big data analytics. There's appliances. We can go down the list, but this is about SQream. My question though is, and this should really get us catapult us into this, and that is, what problem hasn't been solved that SQream is addressing or uniquely addressing?
Yeah, so I'll start with the underlying technology. Let's say that it works and technology is great. So essentially, what we did, empowering the MPP analytics platform with GPUs, we kind of miniaturized the required data center for bigger data sets. So you can do much more with much less hardware to support it. So let's say an appliance that is a 42U can run on, together with a compute and storage, can run on 100 terabytes, and we can do 500 terabytes with a couple of 2U machines, right? So you can achieve much more data crunching and analytics on a much less requirements, software-wise and hardware. And what it means is that customer can load all of their data and not parts of the data, and not spend multitude of hours and people on data preparation, data modeling, putting indexes in place and materials views or whatever, and filter the data so the performance would be reasonable. Our clients do not need to compromise on any of those. They can load all the data, run their queries. Doesn't matter how many joins you have there, doesn't matter how many complexities you have in the SQL statement. and they still get very good results because we have so much parallel processing powers. This is what we enable our customer, and this was not really yet solved by the most of the technologies that you see in the market. So, for example, there was a whole era of Hadoop type of technologies, and they did a very good job and are doing a great job, collecting the data and aggregating the data, but getting insights out of Hadoop. It's sometimes cumbersome. You need a lot of people. You need a lot of time. You need to massage the data and tune it. And we just completely remove all these layers from the daily work of a data scientist or data engineer or a BI user, and they just load the data and just query whatever they want. And this was not resolved until recently, and this is the reason why customers really love what we do for them.
So GPU accelerated data warehouse, I got that. I presume that means you always ship. I mean, obvious. Ship hardware, software. Is this considered an appliance then?
No, no, we sell software licenses. The customer is either renting on the cloud or having servers of vendor of choice with the GPUs on top of them. It can be, of course, IBM power servers that used to be with come with the GPUs. We have a few of those customers. It can be, the usual suspects like Dell or HP, and other vendors that ship commodity GPU servers to customers. It can be any type of storage connected to that. We sell only software licenses.
So it's a software only solution, but I got to believe when your GP accelerated, you've got to configure, or your team would go in and configure the GPUs, or no? And how would that work?
No, so we work. First of all, we have a recommendation for clients of what exactly is the configuration of the operating system, memory, and so on. And we really do not like to change or to do ASICs to anything. We work with the standard libraries and with GPUs as they come. Many times it's installation of a few minutes, maybe 30 minutes, maybe 45, maybe 10 minutes, and up it's going. Everything is standard, and this is our motto because if something was not standard, then we are having troubles in implementations and special talent required in order to work with SQream. We are shying away from that. Everything has to be out of the box and straightforward.
Kind of a silly question, but would you sell your software if the hardware wasn't GPU enabled? It
So
would always have to be GPU enabled.
currently we have to have a part of the mix has to be a GPU. So either it's service on the clouds or on-prem data center, and even on the edge. It has to be a machine with Linux on top of it and GPUs, and our software is running on it. So that's the whole secret of SQream. We are working on additional, let's say, more sets of chips to be part of our offering in the future. But really,
Okay.
currently, the best multi-core for us is GPU.
Why is your GPU solution differentiated? I mean, can you at least give us some kind of indication of what the secret sauce is? I mean, other people could use GPUs, by example. Why
Yeah.
you? What makes you different?
So we architected analytics platform for the ground apps designed for multi-core at large scale. So even IBM has some kind of in-memory offering on top of GPUs. It used to have more of this. If you look at, there are a few other companies that created in-memory GPU database solutions such as OmniSci and Kinetica and Brightlight, uh, and there is even open source that is running SQL on top of GPUs also, pretty much focused on in-memory. So these architectures are focused on in-memory use cases, It's not too many terabytes as opposed to what we created, which is an analytics platform when data sits on the disk and there is no limitation of in-memory. So the secret sauce of SQream is the way we architecture the whole data flow between disks, RAM, GRAM, cache, operating system, and communication paths between the different parties in order to orchestrate very large data sets in complex joins in a fast and efficient way. And again, we are not designed to solve in-memory situations. We are designed to solve very large workloads. So usually we take a workload that took a whole week into 2 hours, or workload that took 7 hours into 5 minutes. This is the magnitude of workloads that we are focusing on. And so if you want to have a nanosecond response time, so you will need some kind of an in-memory solution with the smaller data sets to run on. That's life, that's physics. But if you want to understand, for example, the best way to improve the yield in a manufacturing platform that is loading more than 1 trillion records a day, and run your machine learning algorithm on this new data along with another 12 petabytes of data, this is something that we can do very well for you. And instead of waiting for 2 months or never ending algorithm, we are doing that in less than a few minutes.
So you're not limited by in memory or memory.
No, we are
And
not. We are working on data is in rest most of the time.
what is the distinction between, a lot of times you get in these scenarios, and I've heard some of your team talk about this before. What is the distinction between, all right, you got to add more hardware versus leverage the software that SQream provides? I mean, I presume at some point, there is physics. You always got to add more hardware, but you're also making a case that you don't need as much hardware with SQream. So I'm trying to understand, where that level of distinction is.
Yeah, so we definitely have customers that is using a lot of hardware in order to support bigger data sets and bigger sets of users. We have clients that are using um, multitude of servers and GPUs in order to enable, hundreds of users running millions of queries every day, right? So we can scale the usability and the scale of the queries with more servers and with more GPU, definitely. If you want to run on 8 petabytes and get results in a decent manner, you will probably need 12 GPUs and not only two of them, right? So definitely customers are scaling with more hardware, and if you need more storage, you can scale your storage. But comparably to other solutions, we need less, right? So I'll give an example. There's a very large Hadoop provider that was competing with us, and they needed for a use case of 3 petabytes, they were offering a cluster of 250 nodes of compute, storage, and so on in order to support 3 petabytes. And we offered a cluster that included two of our units, and in addition to that, a little bit more than 10 compute units for the storage, which was not ours. It was another company storage. So in general, even if they are scaling, and this specific customer has today 25 compute nodes with us, and they are running on 12 petabytes in production. So doing that with other technologies and other companies, we probably will exceed the 400 nodes of compute. So this is, again, 25 nodes is a lot of machinery, but it's much less than other players in the market.
Curious now, what's the largest data set you've ever worked with?
So the biggest data sets we run in production is 14 petabytes, and
14 petabytes.
14 petabytes in production. I'm talking about raw data. and
Yep.
a lot of joins and so on. It's not one dimension kind of a data set. They have their 250 trillion records, and this is
Yeah.
growing. This is growing with between half a trillion to a trillion new records every day. We are now in a process of signing a contract with a client that wants to crunch 30 petabytes of raw data in the first year. It's a pretty large semiconductor, so we've never been there, and together we will conquer the size of the data set.
But going back to the secret sauce, then what you're telling me, it's the architecture that you've designed around the GPUs. Do you have a moat there? In other words, is this architecture, this intellectual capital that you have, unless you can expand upon it, I mean, you feel like it's just different and it's proprietary and nobody else has it, and you can do things that other people can't do with GPUs?
So let's start with reality. In the reality, if a couple of guys from Tel Aviv and Petah Tikva created a large scale database with GPUs, I guess there are plenty of other talented people that can do that. All right, so with all due respect to ourselves, I don't think this is a Bimmy Scotty kind of technology. All right, yes, it's
Yeah.
plenty of talented people can do that. However, it's not easy to do that, right? So our IP is pretty strong. We have quite a few USPTOs on our IP around multi-core utilization and orchestration to handle large data sets in the way we do. On our market, talk about SQL statements, joins, a large data set, stream of data between disk memory and GP and GRAM. We were more successful than others on large data sets. But if you look at high intensive compute workloads such as machine learning workloads, you can see a lot of good examples from many vendors, right? So we are pretty unique in the SQL space, and I told you there are other companies and other technologies that are doing something similar on small scale, but on the larger scale, currently we don't have many competitors that are doing so with GPUs. And I think patents are not enough. We have to take the market and make sure we have the edge all the time.
What are your
Yeah.
thoughts and your approach on machine learning and AI?
The place that we see people compromising the most is in the workloads that fits the machine learning algorithm. And they are really happy that they can run on X100 more records because that makes their algorithms and results more accurate. So if we look at our current pipeline and our current customers in production, the biggest production sites that we have are running either machine learning workloads or deep learning workloads, right? We have a fair amount of clients that are running large use cases of BI, so they have dashboards, but these are not even close to the size of data sets that feeds into data science and machine learning algorithms. So this really generates a lot of revenues for us. The frustration of a data scientist from the fact that he cannot play with the biggest data sets he can and change the queries and not wait for a month to have everything tuned for it, but he can do it on the spot and get the results. This is a problem that we solve very well, and we bring more and more value to these types. For example, embedding machine learning tools into our tools so they can run it, embedded in the database as part of the query. So they can run their Python algorithm directly on top of the SQL dataset, or they can use TensorFlow, PyCore, or anything that they want to use as part of the database and not externally, which is important for the performance. One important thing for these guys, and this is part of our messaging, is the fact that they can use the same GPU cluster to run the database query and the machine learning algorithm. They don't need to move the data between the data warehouse into the machine learning platform. So this is a big advantage for us that they don't need to move the data. So definitely, this is a very important go-to-market part of what we do today, and and frankly, the budgets of these guys are much higher than the other guys. So we definitely
That works
we
out.
definitely that we definitely focus on that.
Is Scream always used in concert with Hadoop? I mean, is you can see them in tandem most of the time, or is that not true? I mean, there's other types of data sets.
Yeah. So we have our own data warehouse or database underlying technology. So a lot of times we are working in the same way IBM Netezza used to work when you load the data into the data warehouse and you run the query there. A lot of customers do like it because they get the best performance. But in recent times, customers would like to run on data when it was created. So we find ourselves running directly on top of Parquet file and other types of file system and the way of customers running, including Hadoop.
I got a side question for you. There was one reason I asked you. Do you think Hadoop is dying?
This is actually Hadoop is not dying because it's doing a lot of work in the aggregation space in the large uh, lakes space, but it's completely dead in the analytics side, right? So it did not bring the promise on the analytics side. Customers are having a lot of problems getting the talent in order to get insights out of the data. So I think Hadoop will probably be there quite a bit about large data silos that they aggregate a lot of data because it is doing a nice job there. But on the inside side, you're gonna see that moving away. And actually, our biggest lead our biggest leads are coming from frustrated Hadoop users. I will not say
That's what I wondered.
I will not say the main vendor that is losing customers right now. You probably know the name, but this is our
Yep.
biggest list of clients that at the beginning tactically they just accelerate the analytics on top of that, and then you see them moving all the data sets into something else that is not Hadoop. So I think you're going to see a lot of Hadoop data lakes out there, but on the insides, this is not. I don't see a recovery right now. I see a lot of customers moving away from all the vendors that are focused only on that.
Yeah, that's why I asked the question. I think you answered it well. The the deployment model, I presume, and I thought I read that you can deploy anywhere, on-prem, in the cloud. Is that true?
Yeah,
So it's
and on the
hybrid
edge. Yeah,
and on
so
the edge.
so there are many definitions for the word hybrid. You probably know at least three of
Yeah.
them. But if we think that the world is going hybrid, what I mean is that the thing that will matter most for a specific use case is best practice, right? So some of the use cases will continue to, the good old MPP data warehouse. That will continue, but some of the use cases are going to be lake houses or data lakes where the data is being created in the cloud or on-prem, and you're going to do what is best for the insights and what is best for the cost and performance. But some of the use cases are going to be on the edge, and not all the data is going to move to the cloud, and you need analytics on the device, either on the drone and in the car, on the smart machine or the smart sensor. We see more and more requirements for edge big data analytics, and we are actually are working on embedded devices like that. Not too many use cases, but they are starting to come, and I think that in 10 years from today, you're going to see a lot of the market working on the edge directly. And the use cases are going to be hybrid between best practices. So you can see one query that is running partly on the edge, partly on the cloud, maybe a few types of clouds, and partly on-prem.
Seems like it's taken forever to get to the edge. I don't quite understand why. I would imagine we were further along by now, but I one way or another, I think distribution is and hybrid is in our future. How small is your footprint though on that database to be able to be in like a Raspberry Pi or something on the edge? It's got to have a small footprint. I mean, walk me through that. How would that work?
Yeah, so on the edge, we are available on the line of Jetson machines coming from NVIDIA.
Okay.
It does not have a CPU. It has ARM and a small GPU on top of it.
Mm-hmm.
And if you the cost of it on scale is less than $100, but can be somewhere between $100 to $1,000, depends on the size of the data. We had experiments that can analyze 32 terabytes on such an embedded machine in a size that is less than a smartphone, right? So it's very lightweight. It can work on a DC. It can run 32 terabytes. It can run fast with us. So it's not really a very expensive unit, or it does not consume too much energy. You can actually fly it on a drone if you want, or you can put it inside a sensor. Let's say smart city, and you want to put it on the lights. It's not really expensive, and it gives you a lot of data. And I think sooner than later we're gonna see more and more use cases like that. Not necessarily
I agree.
with this type of analytics, but sooner you're gonna see stuff like that everywhere.
Is your go to market a subscription model?
Yeah, so doesn't matter where you consume it. Our model is subscription, so we have clients that are paying annually, and we have clients that are paying quarterly, and we have quite a few clients that are paying monthly. One of our product lines is called Panoply, and that's the world's easiest self-service data warehouse. And you can click a few buttons and a couple of sources, and you get a data warehouse and a dashboard. So this is with these products, we have clients that are paying monthly. So all of our product lines are uh, um, based on a recurring model. We do have clients that the only thing they know how to do is to install on-prem and pay in advance. Good for them, but even with them, the contract is annually. So the more west you go, the more everybody are working recurring. But on the east side of the world, and we are pretty active there are a lot of customers that the only thing they do is on-prem, and they understand recurring, but they pay after production. No, it's a financial issue, right? How do you recognize revenues, right? So we recognize them recurring. We don't recognize the whole thing, even if they pay.
I mean, how's your charge model? Is it?
So the main thing behind that is capacity, right? So
Yep.
our currency used to be only terabytes, right? How much terabyte is going through our processors? And if you have 6,000 terabytes, you probably will have a bit of a discount, but it's based on how much terabytes is going through our processing. It used to be that we were measuring the size of the storage, so just like the traditional data warehouses, you get it on the storage and you count the storage. What happened in the last 2 years is customers working directly on the Parquet files or C files or whatever files they have, and that's necessarily it's not going into our data warehouse. We had a customer that acquired a license for 10 terabytes. All right. And we said, okay, a small customer, no worries. And one day it sends us a bug. Something is wrong with the query, and we look at the situation, and it's running a query on 300 terabytes. And we're looking at that, and it's running on external tables. It's running on Parquet, and we didn't have a clue. So he bought the smallest license he could, but he's running on very large data sets. So,
You caught him, didn't you?
so yeah, so we were educated. We were educated that customers will do whatever they can do to get value for the technology they have. So today, at that time, we were only billing by the amount of data that we had in our storage that we manage. And from that time, we actually bill by the amount of data that is going through our processors, either on
Yeah.
on-prem or on the cloud. Another part that is more relevant to the cloud, that is some of the customers are used to pay on compute resources, so we have this model as well. But the main model is capacity.
Is there anything on the technical side that I didn't ask you that you wish I would have asked?
I have few comments. That's it, not too much. But you know that technology is advancing, and we are a design partners for many new companies with new sets of chips that are going to bring products to the market. And we see a lot of exciting stuff that is coming to the market. And I think on the compute, on the memory, on the acceleration of the network. But if I would focus on something, I would focus on compute. There are multitudes of new compute designs that are coming to the market. Some of them are, I don't want to exaggerate, but at least much better than the architectures that we see today. And we think that in the next 5 years you're gonna see so much more coming on the compute side in order to handle the zettabytes that you mentioned earlier, right? So
Mm-hmm.
I think you've been around. And 10 years ago, everybody thought that big data is solved with Hadoop, right? It was, you had this and that company, and everything is going to work that way. What happened is data sets didn't stop growing, and it wasn't good enough. And let me tell you, what we have today is not going to be good enough 5 years from today. So I think all the vendors, including IBM, around uh, serving the next generation kind of Uber companies, the next generation kind of Google companies, all of us need to be alert and make sure we can support the clients of tomorrow and work on it and innovate around it. So we didn't see the end of big data. We just started. The other thing, unbelievably, but we are talking for 40 minutes and none of us said ChatGPT even one time. So let's say ChatGPT.
That was great. That was a good one. Very good.
Yes.
Nicely done.
So so so
It-
so look at that. People are starting people are starting to code with data. Nobody cares about technology anymore. Everybody are looking at about the query. The way you ask the questions get you to the right results, right? This is what we're seeing today. Google understood that like 25 years ago. They already knew that the most important thing is the query. But today, people that are not data savvy, they know nothing. If they know how to ask the question right, they get fantastic results. And I think that what we are doing and a lot of what IBM are doing is starting to be commodity in one sense because nobody cares about that anymore. They just want to get the results fast. But we will have to work very hard in order to raise the ante on the performance and the scale of our products, but also to make it, you know, easy peasy. You mentioned we began with easy peasy. Technology has to be easy peasy because nobody is going to use complex technologies going forward, and this is something that we are working very hard on. And I would recommend the other technology vendors to focus on how easy it is to make it tangible to the user that just want to get the results. So this is something that is very important for us. You can look at the user interface of Panoply. It's like the world's fastest data warehouse. 2 click and you get immediately analytics. And I think everybody are going that way.
wow, that was a terrific summary. I'm glad I asked that question, especially the Chat GPT piece. That's fantastic.
Yeah.
Um, is there any technology though? Here's my question. You already answered the one of the last questions I was going to ask you, and that was a prediction because you already talked about the next 5 years. But is there any technology that we're not thinking about today that you think is going to be prominent in the future? I mean, something that I mean, just a guess, but something you think, hey, it's not even on our radar, but you say, boy, I think this is gonna make a showing. Any
Yeah,
thoughts there? Maybe.
yeah, but it doesn't have. It has a lot to do with data. It has nothing to do with what SQream is doing today. All right.
Yeah.
So I think that the interconnect between brain power and compute power is going to blow us mind in the next 20 years. I'm not talking about uh, the processing power. I'm not talking about the neural networks. I'm not talking about the technology. I'm talking about the insights. I think that um, assisted brain technology, think about the fact that you can think on a query and get the results in your brain, right? Same thing in ChatGPT, but inside your brain. That means you think about, uh, you ask a question, I'm just exaggerating. I'm really exaggerating for the sake of
That's
the
okay. I
free
like it.
discussions. And
Yeah, yeah.
think about a question that sounds like, what makes me happy? Boom, you get an answer. And it's a 80% accurate answer. This is something that we're gonna see pretty soon, and I think this will blow us away and will take us to new applications that nobody even dreamt of, including getting to therapy for today. You know, you can't really cure cancer with ChatGPT. But if you add to that neural networks of brains, of many brains, and we have 7 or 8 billion neural networks ready to go
Mhm.
right now that does not consume energy. They are also green. And we can run an algorithm of how to cure a certain type of cancer on that. You get the answer. And I think you'll see more on that also on the brain power and also on the query. So I think this is something that blows my mind every time I think about it, and then I stop because my brain is start blowing up from the inside. So we put that
Sounds
aside.
like a new startup
Yeah,
opportunity, man.
yeah, it does.
What do you read though? You say you're on those planes. Is your go-to? Do you have a go-to reading list? Anything that you could share with the listeners?
Yeah, so I like to read if I'm flying and reading. I like to take some articles, science articles. I'm actually looking at. I'm very interested in curing cancer, so I like to read articles on the latest and greatest on research on articles. Everybody can find it. You can Google that.
Mm-hmm.
It's not a secret. And I like to
Mm-hmm.
listen to podcasts that about stuff that connect business and technology. So these are the things that
Is there a
keeps me
favorite
updated.
podcast outside of this one, of course? Is there a favorite podcast?
Now, your podcast is my favorite, of course.
Yeah. All right, give me the number two then. You got a number two?
So it's a podcast in Hebrew, but I guess there is something in English. The podcast is called Making History, and
Hmm.
it's talking about extremely interested history events that from many options. It's in Hebrew. It is in Hebrew for Hebrew listeners, but I'm pretty sure there's similar to that in English. It's just taking a historic event and you really digging into it in a very profound way.
Oh, I like it. I'm looking at it online right now. Yeah, it looks like it's, is it sponsored by the BBC? I'm not sure.
If it's
But anyway,
an English one, yeah.
yes. Very
I'm
good.
pretty
All
sure
right, now I got a new one on
the
the list.
yeah. And I definitely listened to you, and I heard a lot of IBMers there and a lot of other founders, and it's very interesting discussions.
Very good. Well, I thank you for being here. I always finish with one last question, and that's what you do for fun, man, outside of
So
all the
I play
tech.
chess. Yeah,
Chess. All right.
I really, I play chess, and I really like to spend time with my kids in the sea. So either boating or any other water sport.
Thank you for being here. I learned a lot. I wish you the best in the company. It looks like you guys are doing extremely well. I did my own research. I looked at your website. You guys got things going on. So congrats on the success so far. And look, I think in 5 years, you guys are going to be, at the top of your game. So I think that's my prediction.
Yeah,
Nicely done.
yeah. Thank you very much. I really enjoyed it, and send my best regards to the Big Blue.
I will. Thank you, my friend. I'll see
All
you
right.
next time. And podcast listeners, thank you as always for listening. Hit me on almartintalksdata@gmail.com. If you have any ideas or want to hear something new, we'll get back to you. See you. Bye-bye.